Hello students, welcome to Sreenath. So in this video we are going to discuss the 7th chapter, which is cubes and cube roots from 8th class max. So my name is Karthik Nune. We are creating videos on all chapters and all subjects from class 6 to class 12. So please do subscribe our channel, also like and share our video students. So besides that, we are also providing online and offline tuition students. So please make use of it. So for the tuitions, please go to the description. There is a number, please contact it. So now we are going to start this session, students. So our present 7th chapter is cubes and cube roots. So previously we have discussed squares and square roots. What is a square number and what is a square root? Previous chapter, that is 6th chapter. Here we are going to discuss cubes and what are the cube roots. So before we are getting into the session, just see what are the things, what are the concepts we are having. So first topic is the introduction. Next thing is about cubes. After that, some interesting patterns regarding the cubes. Cubes and their prime factors. And smallest multiple, that is a perfect cube. And there are examples. And cube roots. Cube root through prime factorization method. And cube root of a cube number. That's it. So simple chapter, students. We are going to solve this, complete this chapter. This is the overview of this chapter, students. So now we get back into this session, cubes and cube roots. So first is the introduction. So this is about the story in the so there is Indian greatest mathematician, so who is S. Ramanujan, students. So once upon a time there is another famous mathematician who is Professor J.H. R.D. So he came to visit Ramanujan in a taxi, and the taxi number is 1729. So regarding the taxi number, R.D. described that it is the dull number, but Ramanujan said, so it is not a dull number and it is the smallest number that can be expressed as sum of two cubes in two different ways. Okay, it is the smallest number which can be expressed as sum of two cubes in two different ways. So we can express this as 12 cube plus 1 cube and also as 10 cube plus 9 cube. No other smallest number is there which can be expressed like this. So this was told by Ramanujan. That all of a sudden there is a shock. So after that, this 1729 number is known as R.D. Ramanujan number. Okay, students. So that is the thing. So how it has been done? How he knows Ramanujan? So basically he loves the number. That's why he always think about the numbers. He will thought about the numbers. He uses the numbers. That's why he will know such interesting patterns about the numbers. In this chapter also, we will see some interesting patterns regarding the cubes, students. So our present interest is among cubes. Previously we have discussed about square numbers. Now we are going to discuss about cubes or cube numbers, whatever it may be. So basically the word cube is used in geometry, students. So a cube is nothing but a solid figure which has all sides equal. Okay, so how many cubes of side 1 centimeter will make a cube of side 2 centimeter? So what is happening here? These students, we are having a cube. So this cube having 6 faces and every side length is 1 centimeter only. So now if you want to make a cube, like this, whose length side length is 2 centimeters. Basically previous cube side length is 1 centimeter. Here we want the cube whose side is length is 2 centimeter. So to make this type of cube, how many this type of cubes we require? So we will tell it clearly. So to make a cube whose side length is 2 centimeters, how many cubes are required? How many 1 centimeter cube unit length, 1 centimeter side length cubes are required? How many? Can you tell? Yes, we require 4. Is it, students? Is it correct or not? Tell me quickly. Yeah. So how many cubes we require, students? So if it is cube whose side length is 1, so if you place another cube here, so whose side length becomes 2 centimeters. Okay, so again you have to place here again cube. So this side length also becomes 2 centimeters. So but this side is, there is no 2 centimeters side, so we have to again place another cube. So this side 2 centimeters, and so this side becomes also 2 centimeters. Okay, I will redraw it here. So this is the thing, and this side is 2, this side is 2, this side is 2, and this side is 2. But coming to the depth of the cube, so we are having this side length is 1 centimeter only. This is also 1 centimeter only. If you see here downwards, so for that what we require, we have to place some other cubes. Here we have placed 4 cubes to make 2 to 2. So we have to place another 4 cubes in the downside, so that we can make a cube whose every side length becomes 2. So finally, apart this part, how many cubes we require? How many cubes required to make a cube whose side length is 2? We require 8 cubes. Okay, students. Next thing, if you want to make, so for a cube of 2 cube of 2 centimeters. Suppose if you want cube of 3 centimeters, how many cubes? If you do the factories, it will become 27 cubes. You require 27 cubes. So like this goes, here these numbers 8 and 27 and here 1. Okay, students, these are called as perfect cubes or perfect cube numbers. Perfect cubes. So cube of 2, that is 2 cube, and this is 3 cube. Okay, students. So 2 into 2 into 2, 2 into 2 into 2, 2 2s are 4, 4 2s are 8, 3 into 3 into 3, 3 3s are 9, 9 3s are 27. That's it. 1 cube as 1 into 1 into 1, that is equal to 1, and 2 cube as 2 into 2 into 2, that is equal to 8, and 3 cube which is equal to 3 into 3 into 3, which is 27. These are called as the cube numbers or perfect cube, students. So what is the definition of a cube number? So cube number is a number. It can be expressed as product of 3 equal numbers. Product of 3 equal numbers. Suppose if you take 27, we are expressed it as product of 3 numbers whose numbers are equal, 3 3 3 only, like that. Or if you goes beyond that, is a 9 a cube number? No, 9 is not a cube number. Why? 3 into 3, there is only square, not cube. So here these are the numbers 1 2 3 4, and these are the cubes of this number. 1 cube is 1, 2 cube is 8, 3 cube is 27, 4 cube is 64, and 5 cube is how much? 125. Like that this goes on. So these are the cube numbers: 1, 8, 27, 64. All these are cube numbers, students. Okay, so From 1 to 1000 there are only 10 perfect cube numbers. Then from 1 to 100 there are how many perfect cube numbers? Can you guess? Try it. I am leaving it to you. If you see here 11, 12, 13, all these numbers, and these are the cubes. Here just observe the even numbers, these, and this. So if you observe the even numbers and their cubes, so their cubes are also even. And coming to the odd numbers also, there are also, if you coming to the odd numbers, they are odd. So consider a few numbers, students, whose units place have 1, and find the cube of each of them. Okay, that is let 1, 11, 71, like that numbers, and find the cube of them. Observe the cube number of them, and what is there in the their unit digits. Do it by yourself. Here there are some interesting patterns, students. So what are those interesting patterns? Some interesting patterns. First thing is adding consecutive odd numbers. So we are having the odd numbers. 1 is the odd number, it will give rise the 1 only. If you add the next consecutive odd numbers, that is 3 plus 5. If you add the next consecutive odd numbers, that is 7 plus 9 plus 11. If you do like that, 1 is 1, 3 plus 5 is 8, and this will give rise to 27. And if you further go 13 plus 15 plus 17 plus 19, it will give rise to 64. Just wait, see, it can be written as 1 cube, and it can be written as 2 cube, and it can be written as 3 cube, it can be written as 4 cube. So just see students, such a interesting pattern: 1 cube, 2 cube, 3 cube, 4 cube. How you are getting 1 cube, 2 cube, 3 cube and 4 cube? As adding the successive odd numbers. How beautiful it is. So we can represent y plus y, 1 plus 9 plus 11. So this is interesting. So using the above pattern, can you express these things? So if you go beyond 6 cube, for that we have to add what? Just extend it for 5 cube. How you will get 5 cube? 5 cube is 125. So for that 21, 23, 25, 27 and 29, you have to add 5 things. 4, 3 terms, 2 terms, 1 term. Next is 6 cube. Here you have to add next 6 terms, that is 31, 33, 35 and 37 and 39, 1, 2, 3, 4, 5 and finally 41. If you add all these things, what you will get? Comment in the below. Obviously you will get, students. Like that you have to express these things. Okay. And using the above pattern, find the values of the following. So you can find these values also. It is so simple. How to find the 7 cube minus 6 cube? So simple, students. If you do this, and if you do this, students, it is like that. You will know the value, and you will have the next value also. You can simply subtract these values. You will get. Okay. Next, cubes and their prime factors. Wait a second, students. Yes, let's start. Cubes and their prime factors. Okay, students. So prime factorization of a number. We know what is meant by prime factorization. Okay. Now we will find the prime factorization of a particular number. So if you take the number 4 and 6 and 15, these are the numbers. Prime factorization is 2 into 2. For this, 2 into 3. For this, 3 into 5. So regarding that, if you take the cube of this number, that is 4 cube, and it is 6 cube, and it is 15 cube, how we can write? 4 cube is almost 64, and it is prime factorization like that, 2 into 2 into 2 into 2 into. So how many, if you see here, how many 2's are there? 6 2's are there. We can make 3 as 1 cube and 3, you can make it them in the form of cubes, that is 2 cube into 2 cube. Okay, that is the thing. And this is also having 1 2 3 4 5 6 numbers, and 3 are 2s and 3 are 3s, like that, students. So what we can get from these things? Have you remembered this? A power m into b power m is equals to a into b whole power m. This is the thing happening here, students. So if you do the prime factorization for 2 and 6, it will give rise like that. We can write it as 2 cube into 3 cube, and 2 into 3 whole cube, and 2 into 3 is 6, and we can write it as 6 cube. So whenever you can write any number like in terms of cubes, we can say that number is a perfect cube. 6 cube is a perfect cube. If you see here, there are only 2's, only 2 2's and 3 5's. So if it is having another 2, we can do it as a perfect number, perfect cube, but it is not having another 2. That's why it is not a perfect cube. If you want to make as a perfect cube, you have to multiply it with 2, then it will become perfect cube. That is the thing, students. Here there is a number given and we have to check for that number. Is 243 a perfect cube or not? How we will know? First thing is, you have to write the prime factors for it. If you go writing on it, you will get that. You go and do this 243. It will be in 3 table. How many times? 7 3's. How much, friends? 8 3's. 8 3's are 24. Is it? Yeah. Next, again 3 table. How many times? 27 3's. Again 3 table, 9 times. Again 3 table. So now if you write it, 243 is equals to 3 into 3 into 3 into 3 into 3. 5 3's are there. How we will make for cube numbers? Make 3 as a group, but here these 3 as a group, and we can take 1 3, but here there is no group of 3, so it is not perfect cube. How we can make it as a perfect cube? If you multiply it with 3, then these 3 will becomes one group, then it is a perfect cube. Smallest multiple, that is a perfect cube. Okay. Raj made a cuboid of plasticine. Length, breadth and height of the cuboid are 15 centimeters, 30 centimeters and 50 centimeters respectively. So length of a cube is 15 centimeters, breadth of a cube is 30, and height is 15 centimeters, students. So this was made by Raj, and Anu asks how many such cuboids will she need to make a perfect cube. Okay. Okay, student, can you understand it? So Raj had made a cuboid, so whose dimensions are 15 into 30 into 15. So next, Anu, what she wants to make a perfect cube. So for a perfect cube, length and breadth and height all are same. So to make a perfect cube using these cuboids, how many this type of cuboids will be required? How, students? So for that, first thing is, we will have to find out the volume of this total number cube. So it is not a perfect cube, but we'll find this number volume. It will becomes what? That is 3 into 5, and 15, that is 2 into 3 into 5, and it is again 3 into 5. So for a perfect cube number, we must have triplets, 3 common things. Here 3 3 3, so we can write 3 into 3 into 3. Okay, it is one group, and we are having 5 into 5 into 5, so another group is 5 into 5 into 5. So it is good thing, students, and we are having some extra things, that is only 2. So if we are having 2 more 2's, then it will become a perfect cuboid. So what we have to do is, we have to multiply it with 2 into 2. This is the addition. So to make this as a perfect cube, you have to multiply it 4, then it will becomes perfect cube, which means you required 4 such cuboids to make a perfect cube. 4 cuboids. That is the thing. We will solve the example, students. Example 2. So, is 392 a perfect cube or not? We have to tell. For that, what we have to do? First thing is we have to find the prime factors for it. So we can write, so 392, if you want to write, do it like that. So if you do like that, so it is 2 ones are 2 and 4 twos, so it will becomes 19, and 9 twos are 18, and we can 12, 6 twos are 12. Then again 2 table, so can write it as 9 twos are 18 and 16, 8 twos are 16, and again 2 table, 4 twos are 8 and 118, 9 twos are 18. So it comes, so here only 7 table will cancel out. So we can make these 3 as group, and we can't make these 3 things. So here 2 into 2 into 2 is one group, 7 into 7 is another group. We need another 7 to make this as a perfect cube, but this is not a perfect cube. So if you want to make this as a perfect cube, we have to multiply it with 7 so that we can make it as a perfect cube. That is the thing, students. The smallest number which we have to multiply it to make it a perfect cube is the 7. That is the thing, students. Here there is thing 53240. Is it a perfect cube or not? Same procedure, students. So if not, then by which smallest natural number should be divided so that it coefficient is a perfect cube? So do the same thing like this, students. Find out the prime factors and make 3 as one group. So what are the remaining terms extra which are like having 2 or 1? Such number has to be divided. Again 1188 is a perfect cube or not? We will do this thing. 1188. If you do this thing, students, if you do by 2 table, it is 5 twos are 10 and 1 is there shifted, 9 twos are 18 and 4 twos are 8. Again if you do 2 twos are 4 and 19, 9 twos are 18, and there is 1, 7 twos are 14. That's it. Next thing is that, students, it will goes in line a 3 table. So that is how many times? 9 3s 27, there is 2 again 27, 99. So for 99 we use 9, that is we can use 3, we can write it as 33, and again we can use 3 and 11. This is the thing. So we have to write 1188 is equal to 2 into 2, 3 into 3, 11. So is it a perfect cube? No, not at all. Why? Because there are only one group is there. This group and this group are not there. By which smallest number should be divided so that the coefficient is a perfect cube? So how much number we have to divide it? So we have to divide it with 11 into 2 into 2. So 2 is 4 and 11 4 is 44. We have to divide it with 44. Why? Because these terms have to be eliminated, then only it will become a perfect cube. You have to divide it with 44, then you will get a perfect number, cubic number. This is also similar to that, students. Next, coming to cube roots. How to find cube roots? So previous chapter, first thing we have discussed about square number and we have discussed about square root. Okay, students. So if there is a number like that 4, it can be expressed 2 into 2, that is 2 square. It is the square number. And what is the square root of this number? That is nothing but 2. So in this case we are making 2 as one group, 2 as one group, and one out of it we are picking up, and that is the square root. Similar to that, here we are having cube and cube roots. Here cube number or cube. Oh, what is the cube? Well known cube is that 8 is the cube. We can write it as 2 into 2 into 2. It is the 2 cube. Then what is the cube root? So what is the cube root? We represent cube root like this and we place 3 here, students. Cube root of 8. So here we are making 3 as one group, and we will pick up one out of the 3 and it is the cube root. Here we are making 2 as a groups and we take 1 out of it. Here making 3 as a group and we are taking 1 out of it. So it is called as cube root. So, and 2 cube is 8 and the cube root of 8 is 2. Statement and the inference. So if you see here, 2 cube is 8 and cube root of 8 is 2. 3 cube is 27 and cube root of 27 is 3. It is the inverse operation. Okay. So how addition is the inverse to subtraction and subtraction is the inverse to addition, like that. Cube number is the inverse to cube root and cube root is the inverse to cube number. That is the thing. So how to find out the cube root? Through prime factorization method, students, which I have already told you like this. First thing is we have to find the prime factors and make 3 as a group and pick 1 out of it, 1 out of every 3. Then it will give us rise the cube root. We will solve this, some examples. So here there is 3375. If you find out the prime factors for it, you will get them as 3 into 3 into 3 into 5 into 5 into 5. So these are the prime factors for 3375. Here what we have to do is we have to make 3 numbers, 3 same numbers as a group. So this as one group and this as one group. So out of this group we have to pick only one number. So this is 3, and out of this number we have to pick one number, that is 5, and we have to multiply these things. So that is 3 5s are 15. So this cube root of 3375 is equals to 15, students. In this way you have to do this task. Okay, students. So here are their examples. Example is there here. So 8000 is there. We have to find the cube root for it. First thing is for prime factorization. If you go by 2 number, that is 4 2s are 8 and 0 0. Again 2 2s are 4 and 0 0 0. And again 2, that is again 2 table. Again 2 table. We know these things are most common, that's why I'm going fast. 252s is 500, 502s is 1000, we know 1002s is 2000. And again we can get 2 table, that is 125. But here we can't get the 2 table, we use the 5 table, that is 25 5s. And again 25 can be solved by 5 5s. So if you write the for 8000, if you count how many 3s are 1 2 3 4 5 6, there are 6, no, 6, 1 2 3 4 5 6, and how many 3s? 5 3s. So what I have told you, after completing the prime factorization, pick up, make 3 groups. This is the 3 and this is the 3 and this is the 3. So pick one out of it. 2 2 5. Multiply this 2 2s are 4 into 5, 4 5s are 20. So therefore cube root of 8000 is equals to 20, students. In this way you have to do the task. So can you do as it is for 13827? You can. First you have to do the prime factorization, find it and check with this number your prime factorization. So if it is same with your prime factorization, go that. So make 3 as group. Out of these 3 take 1, 2, out of these 2 take 1, out of these 3 take 1, out of these 3 take 1, and multiply them. You will get. That's it, friends. So simple it is. Next thing is cube root of a cube number. Cube root of a cube number. Cube root of a cube number. That's it, friends. So if you know that the given number is the cube number, then follow the method can be used. So how to find the cube root of a cube number? We can use follow the prime factorization method previously, which we have discussed. Sometimes it is very lengthy process, we can't find prime factorization. On that time we can use this method to find easily. This is by division method or whatever may it can be. So if it is the number 857 375, so first thing is we have to make three numbers as a group. Okay, it is the first group and it is the second group, and we will estimate the cube root of the numbers. So we are making these three digits as separate groups. So first thing is we will take this group. Okay, and for the required cube root, we will, by seeing these things, to the required cube root we will give the units place. If you see here, 375 will give the ones or units digit of the required cube root, friends. So here the 375 ends with 5, so that 5 will comes in the cube root. So for this cube root of this, it is ends with 5, so its cube number is ends with 5, so its cube root must have the 5 at the end. Like that we will do the assumptions. Now take this group. From this group what we can then, we know that 9 cube is 729. If you do the 9 cube, it is 729, and the 10 cube is 1000. So between these two cubes 857 lies. So it will lies more close to what? It will lies more close to, so we take the ones place of the smallest number 729 and as the tens place of the required cube root. So we get it as 95. What we are taking as, we are taking 9 in this and we are taking 5 in this. You will get 9 in this. That is 95. From this it is closer to 9 cube. Thus we are taking 9. So this is the cube number. So this is the estimation of cube root, students. Okay. So here is the another process if you want. So 17576 we have to estimate it. Make them as a group. So this 576 is one group and 17 is one group. So from this 576 number, so what we can take, first we will take, and it has a 6 in the units place. So the required cube root must also have 6. Okay, cube root will have 6. And if you take the other group, that is 17. Okay, and it is very clear near to 2 and 3. So we are taking it as, it will be between 8 and 27. That's we are taking it as 2. So finally it will becomes 26 approximately. So this is called estimation, students. So finally our chapter is completed. Hope you have understood well, students. If you have any doubts, please feel free to comment below. I am happy to say that we are starting tuitions both online and offline. So please contact us. There is contact number in the description. So please like and share our videos. So please subscribe. Go through the channel playlist. We will have all the chapters and all the subjects from class 6 to class 12. Make use of it. So now our chapter is completed. Now we are going to see the summary of this chapter. Just we will see the summary, students. Okay, like a quick revision you can assume it as. Summary. So chapter name is cubes and cube roots. So what is meant by cube? So any number which can be represented as 3 equal factors, whatever it may be, is called as product of 3. It is called as cube number or perfect cube. And there are some interesting patterns. So if you add consecutive odd numbers, you will get like this. And prime factors of a number and of a its cube. And next thing is how to make a perfect cube. And next thing is cube roots. So cube is the inverse of cube root. Cube root is the inverse of cube. We'll represent it with like this symbol. And cube root through prime factorization method. First thing is you have to find the prime factorization, and next thing is you have to make three numbers as one, three equal numbers as one group, and you have to pick one out of the group. And cube root of a cube number. We'll going through with estimation. That's it. Chapter completed, students. Hope you have understood well. Have a nice day. Bye bye students.